Behavioural economics on a post-it, number 9. This short video and this post-it note are focused upon what's called the Markowitz hypotheses, named after Harry Markowitz, who developed this particular hypothesis. Harry Markowitz is another economist that won the Nobel Prize for economics, and he presented this this hypothesis, I think in the 1950s. It was in the 1950s he published this hypothesis. It's got some similarities with prospect theory, in that it proposes that people will not have a consistent risk attitude across different choices. But it differs a little bit. It differs quite substantially from prospect theory, as I'll explain in a moment. It's not been anywhere near as influential as prospect theory, partly because prospect theory predictions tend to, in terms of the published evidence, tend to hold up more robustly, I think, perhaps, than the Markowitz hypothesis, but also partly because, for whatever reason, the Markowitz hypothesis is less well known, and yet I think it does have some important insights. So, as I said a moment ago, the standard, and as I've said in previous post-it notes, the standard rational choice model, or standard economic theory, assumes that people will have a consistent risk attitude across the different risky choices that they face. Namely, that people ought to be consistently very close to risk neutrality, maybe mildly risk averse in some circumstances. Now, what Markowitz proposed is that, depending on the size of the outcome that's presented to people, that size of outcome can influence the risk attitude that they demonstrate, right? So, just going through these 4 different gambles, number 1, 2, 3, and 4. What Markowitz proposed is that when people are offered a chance of winning a relatively small amount of money, they will tend to be risk-seeking. So just for example, if we were to offer people this little lottery ticket here, number 1. So I use my piece of paper to separate these out a little bit. So number 1. We could offer people a 10% chance of winning £1, otherwise 90% chance of winning nothing, or just give them the offer them 10 pence for certain. Now, if you remember back to my previous post-its, the expected value of a 10% chance of £1 is just 0.1 times £1 equals 10 pence. Isn't it right? So you ask people whether they would prefer either the certainty of the expected value or to take the gamble. Now, what Markowitz proposed is that in most instances, people will just choose the gamble in that particular case. The expected value, the certainty of the expected value, is not worth much. Maybe even the gamble is not worth that much. So people might just plump for the gamble in this case, right? So they'd be risk-seeking when faced with small magnitudes of outcome. However, when they're faced with large magnitudes of outcome, large outcome magnitudes, in other words, say, for example, I'll put the gambles the other way around here, but a 10% chance of winning £1 million, otherwise to receive the expected value of that gamble for certain. Expected value of 10% chance of £1 million is just 0.1 times 1 million equals £100,000. So just imagine what you might choose in that particular scenario. Markowitz proposed that most people would choose the certainty of the £100,000 rather than take the 10% chance of £1 million, right? The certainty of £100,000 over the 10% chance of £1 million, right? Now, if they do that, they will be demonstrating risk-averse attitude. They wouldn't like to take the risk, which makes sense because the certainty, the expected value, is a very significant amount of money for most people in this instance, right? Now let's consider losses. Number 3, you could either take a 10% chance of losing £1 a 90% chance of losing nothing, but there's a 10% chance that you could lose £1. Or you could just pay up 10 pence. You could just pay over 10 pence for certain. Now, what Markowitz proposed there is that, and this might be, when you consider this option, you might disagree, but Markowitz proposed that in this scenario, people would prefer just to pay over the 10 pence, a very small amount of money in this case, and to take the small chance of losing a larger amount. It's if you think about it again, it's a sort of a classic insurance scenario, right? You pay the premium to cover yourself in case you experience a small chance of losing a much larger amount, right? So Markowitz did propose that people would be risk averse when faced with small losses, the potential for small losses. And then finally, people could be presented with either the 10% chance of losing £1 million, in this case, 90% chance of losing nothing, or just to pay over the expected value of that particular gamble, which would be to pay over £100,000, right? £100,000. Just give £100,000 over, or take the gamble where there's a 10% chance that you could lose £1 million, right? Did I say £100,000 there? Pay over the £100,000 for certain, or take the 10% chance of losing £1 million, right? And Markowitz proposed that in this instance, people would plump for the gamble. There's a 90% chance that they won't have to pay over anything. So people would take the gamble in this instance, according to Markowitz, rather than just to give £100,000. Right? So you can see that depending on the outcome magnitude, people will, according to Markowitz, demonstrate a different risk attitude. i.e. they'll be risk-seeking if they're faced with small gains, or the potential for small gains, or the potential for large losses, and they'll be risk-averse if they're faced with the potential for large gains, or faced with the potential for small losses. Right, that's what Markowitz is proposing. Sorry about that. Now, this differs from prospect theory because prospect theory says really nothing about the magnitude of outcome and its effect upon risk attitudes. Right? So Markowitz is adding in a sort of a different nuance, if you like, in what might affect people's risk attitudes. Now, if you were to draw up a value function over outcomes according to the Markowitz hypotheses, if you remember back from previous post-it notes, the value function in standard economic theory would be everywhere marginally concave, perhaps, so mild risk aversion, if they were marginally concave. If you remember for prospect theory, it was assumed that people would have a concave value function in the domain of gains and a convex value function in the domain of losses, i.e. risk-averse behaviour in the domain of gains and risk-seeking behaviour in the domain of losses. Markowitz's value function is more complex. It would depend upon the magnitude of the outcome that people face in terms of the influence that might have upon their risk attitude. So there would be risk-averse for large outcome magnitude and then risk-seeking for small outcome magnitude, and risk-averse for small outcome losses and risk-seeking for large outcome losses. So there we have it. That's the Markowitz hypothesis. It's not discussed that much within behavioural economics. I think there is some potentially important insights within that hypothesis, but I've just included it here as a post-it note for completeness, so that you understand that the challenge to consistent risk attitudes extends beyond prospect theory.